So yeah, welcome back. And last time we did talk about, we're going to tackle basic shapes that you can have on the Cartesian plane. But keep in mind, in this video, the thing that we're going to talk about is not limited. Of course, you can always go outside the box and maybe discover some of the shapes for yourself. So without further ado, let's start with this. But before that, let's quickly go through what we will tackle today. So by the power of video editing, we are going to talk about Okay, so for example, if we want to describe the straight line by using formulas, first we need to know things. In this case, first thing first is the slope. And then the second thing is the y-intercept, which in this case is the y-offset. Like for example, you can also treat it as we have a point over here with this kind of slope, and then it has been pushed from the origin down over here. What is the offset over here? Now, from the look of it, you can immediately see, okay, y-intercept is 2, but in this case we need to make sure rigidly it is actually 2 in this case, and it's not guessing or something like that. So yeah, without further ado, let's start with the slope. So in this case, most of the time we define slope, or most of the time we call it m, and we define it as change of y divided by change of x, or me personally, I call it delta y divided by delta x. In this case, what is delta y? Which is the difference between the 2 points but along the y-axis. And then what is delta x would be something like the difference between 2 points but along the x-axis. So in this case, if I were to connect the lines, there we go. So in this case, you can see the green line over here is actually the difference of the 2 points y0 and y1 along the y-axis. And then the red line over here is the difference or distance along the x-axis in this here. So basically, we're just taking the green line divided by the red line. So in this case, yep, that is our slope. So assume that we know the exact positions of the 2 points. So in this case, y1 is 1, 2, 3, 4, 1. So the y-coordinate of y1 is 1. And then this one over here, 1, 2, 3, 4, 5. So this one over here is -5. 1 minus -5, you have 6. So delta y is 6. Now, what about delta x? So the x coordinate of y1 is 4. And then for y0 is also 4. So, no, it's -4. So we take 4 minus -4. So you have a delta x of 8. So our slope, or m, is 6 divided by 8, or reduce it, you have 3 over 4. So perfect. What does it mean? 3 over 4, what does it mean? 3 over 4, you can interpret as something like, for every 4 steps in the x direction, you have to move upwards y in 3 units. So that's basically the idea of slope. It's like telling you for how many units you go along the x, you need to go how many units up or down along the y-axis in this case. So that's the slope. Alright, but what about the y-intercept? Alright, let's take a look at one thing first. Since we know m is actually our delta y, or I call it dy, but whatever, by dx. Alright, cool. And what is our dy? dy is our point 1. Over here it's y1 because it's yellow, but you know what? In the video I'm going to call it p1 in this case. So delta y is p1's y minus p0's y, and then divided by delta x, that is p x minus p0 x in this case. So yeah, this over here is the definition of the slope. So let's assume that we move our point, which is we move our first point, which is y0, and then we will push it to over here. As you can see, they are still describing the same line, because after all, the straight line were to be expanded in this case. But here's the thing, when our first point, or p0, when its x coordinate is 0, you can see that its y coordinate is actually what we call the y-intercept, or sometimes I call it the y-offset. So back into this like slope formula over here, if p0x is 0, so we plug in 0 over there, then we know p0y is the y-intercept, and we normally call the y-intercept c. So if you rearrange this whole thing, you can actually get m equals p1y minus c divided by p1x. And then if you rearrange this whole thing again, you can get p1y is equal to m times p1x plus c. And then what is p1y? What is p1x? I don't know. It literally can mean any point on the line. So you can actually simplify it as x and y. And we have our formula for the line. So a straight line can be described as y equals mx plus c. There we go. So that's one of the way that how we can actually describe a straight line. So back to this thing. If we take a look at our formula, we know we need to describe y equals mx plus c, and then we already know m, but now we have to find what is c. Well, one way though, we can actually just pick one point over here. Let's say, for example, 4, 1, right? When this point is on the line, it means that the coordinate of this point fulfills the equation that we want to find. So we can actually plug that into our equation over here. So we can say when our y is 1, then we know exactly our x will be 4. And then what is our gradient? What is our slope? A while ago we just discovered is actually 3/4. So if you do some algebra and then move things around, you can actually make sure that our c, or y-intercept, is 2. No more guessing. And with that, we can know our straight line is y equals 3/4x plus 2. Wait, no. it should be -2. Oh boy, my brain's not braining. Okay, so did a mistake. If you do the algebra in this case, c will be -2. So the straight line formula, or the formula of the straight line, will be y equals 3/4 x minus 2. So that's the straight line that we're looking at, and that's the straight line that we want to describe. So yeah, next time if you want to describe a straight line, make sure you know the 2 points, and then you find the slope, and then you find the y-intercept, and then you should be good to go. So yeah, our next shape is the circle. So yeah, what do we know about circles? Basically you just need a center point, and then you need a radius, and then fixed radius along all the angles, and then swoop, now you have a circle, which is the same idea over here. In this case, assume that we have our center point, which is y0, or we call it p0 or whatever, and then we have a specific radius. Well, from the looks of it, you can immediately know our radius is 5, but assume we call it r in this case. So, and then we also know p0s, or our circle center points, coordinate. So in this case, it's actually 2, 1. So with 2, 1, and you know the radius is 5, how are we going to describe this circle in a mathematical term in this case? So in this case, if you saw these other points already here, you have sharp eyes. But just in case, let me quickly do this. There we go. And that's our lovely right triangle again. But why do we need this? Alright, so here's the thing. You might see that the yellow line over here is our radius. In this case, 5. This looks similar to you. But in this case, we also have our red side. What is our red side? Our red side, okay, so basically, we have to start with picking any random point. Let's say y1 in this case, or p1 in this case. Like, this point has to be on this circle. Excuse me. It has to be on this circle in this case. So let's just say, okay, I pick p1 over here. For convenience, but of course you can pick any point you want. So in this case, the red side is, once again, delta x again. So it's the difference between 2 points, but along our x-axis. And then we have our delta y, which is the difference between the 2 points along the y-axis. Now, assume that you haven't picked a convenient point, like let's say you just pick a really bad point, so you don't know exactly what is your delta x, what is your delta y, but it's okay, never mind. Let's just put them into the formula in this case. So if you take a look at this thing, you know that this is a right triangle. So when you look at right triangles, the first thing that should come to your mind is the Pythagoras theorem. So Pythagoras theorem just tells us, in this specific case, red square plus green square is yellow square. In other words, r squared, or radius squared, is delta x squared plus delta y squared. So now, what do we have? We have our r, and then we have our center point coordinate. So in this case, it will become useful. So in this case, let's assume that, because in this case, the way that we are going to describe our circle is any given point on the circle. So the coordinate for y1 or p1, because p1 can be anywhere on the circle. So the coordinate for p1, let's just call it x comma y in this case. And then the coordinate for our center point, let's call it a comma b in this case. So what is delta x? So delta x, you take the moving point or p1's x coordinate minus the center point coordinate in this x coordinate in this case. In this case, you have x minus a. And then for delta y, which is the y difference between the 2 points. So in this case, you have y minus b in this case. So if you plug that thing in, you should be able to have x minus a, take this whole thing squared, and then you plus y minus b, and then the whole thing squared. You add them together, this should be r squared. Just in case, to make things a little bit clearer, let me write it out. So in this case, we have our yellow side over here, which is the radius. And then we have our red side, which should be x minus a. And then we have our green side, which should be y minus b. So there we go. So basically, this thing squared plus that thing squared is this thing squared. So as long as the point fulfills to be this right triangle, it's on the circle, and therefore you can actually describe the circle by using the Pythagoras theorem. And as a homework or an exercise, just in case, a Cartesian plane can also extend in the third dimension as well instead of a flat plane. So if you have time, you can try to think about what is the formula of a sphere. So that would be an exercise in this case. So yeah. So yeah, basically these are some of the basic shapes on the Cartesian plane in this case. But of course, there are still many other, many basic shapes in this case. Like one of the classic basic shapes we can have is the parabola. It would be something like ax squared plus bx plus c, and you ended up with 0. But of course, you can end up with many powers. So in this case, you can go up until x to the power of 4, x to the power of 5, or whatsoever. And then you can have a lot of weird shapes or whatsoever. But yeah, so basically, one thing to quickly wrap up would be something like, if you have a shape that follows some specific pattern, then it can be written as a formula in order to describe it on the Cartesian plane. So yeah. Now, of course, if you're watching this episode until this very point, congrats! You have survived the brain damage thing, whatever. But yeah, of course. And then, yep, I'll continue to work on other episodes, and I'll see you in the next video. Bye-bye!